We have all used keyboards, mouses, and touchscreens to navigate a maze. But when you can do that with your brain, it feels like a next level of science fiction. This is what we tried to realize in our hackathon project. We were 4 people, Purva, Ashka, Jaspreet, and Sahana, and we made EEG Maze. We had set out to build a real-time BCI game that allows users to navigate a 2D maze using EEG signals alone. To accomplish this, we used the g.tec Unicorn Hybrid EEG headset and the P300 module, and linked it with a Python-based Maze GUI. The motivation behind our project was really to demonstrate how brain signals can be converted into commands, and to further explore the P300 tool in the Unicorn Suite. Our solution required transforming attention into action. We started this off by acquiring signals from the Unicorn Hybrid EEG headset. We then used salient stimuli to evoke P300 signals. We used the Unicorn Suite to filter things out, and the P300 classifier to classify it as a top, bottom, left, or right arrow. This information was then streamed using UDP to the Pi game, and the Pi game was then responding to the input and controlling the game. Things right took quite a bit of time. We had to maximize the P300 signal. We looked into literature. We tried to use salient visual cues. We tried to tune the stimulus timing, like flash duration and interstimulus interval. We tried to look at the difference between P300A and P300B. The biggest challenge we faced was actually parsing the UDP and LSL outputs that we got from the P300 speller to actually transfer it over to Python and have it become interactive. Data latency was also something we had to look at. Despite all the problems we faced, we did end up making a working prototype. We have 3-directional control and a latency of 300 milliseconds. As you can see, it's actually moving. Yes, the 4th-directional key was not working, but that is on our list. Improving classifier accuracy and reducing the game latency is also something users would value. From this experience. EEG game integration needs to have good latency. Modular design and interfacing is harder than we think, and celebrating every little win makes it a lot easier to deal with a setback. A big thank you to Queen's University for hosting us.